to still continue the lucky numbers game. And what we want to do now is the logic for the game. So previously, we had the cells being activated for player one. So like when player one's turn, I cannot place on any of player two's grid. Okay, I only can place on player one. So something like this. Okay, so yep, the logic is there. Okay, you can put on the grid. Okay, but right now what we want to do is, because we want to make sure that when you place a number, it is greater than the neighbors on his left and his top, and smaller than the neighbors on his right and his bottom, then it's able to be placed there. If not, we should not allow it to be placed. Okay, so what we will do now is we will code the logic for that. So right now, we already know how to get all the like clovers to be working and stuff. All we need to do now is to program a logic whereby you can only place the number, okay, at a grid cell that it's that fulfills the criteria of valid placement. Okay, so that's what we're going to do now. Okay, let's go back to our script. So okay, so let's just take a look at the scripts. Okay, in our scripts, what we have is the game manager again. Let's go open the game manager. So that should be something that is controlling the entire game. The game manager controls the entire game. So we will edit the script of the logic placement of the buttons over at the game manager. So let's take a look what we will do. Okay, let me just put this to one side. Okay, so this is the game manager right now. Okay, first up, we need to figure out what are the clovers position. Okay, so we open the clover script as well. So the clover itself, based on what we have did last time, we have a grid num. Okay, and we also have a my number. Okay, we don't need the original number because original number is the number that is like from 1 to 40. Okay, that actually specifies the both the number and the color. Okay, because initially when we did the clover, we did from 1 to 40. Okay, what we really interested in is my number, which is the number of the clover itself. Okay, so what we want to do is, where's the function to get the valid clovers? Let's see here. So we are doing this part here to do adding the activation. So let me just change this. Only place the clovers in positions that can be, okay. So what we'll do now is we'll have a set, okay, of clovers that can be activated. Okay, so what we'll do now is we'll have a grid variable. So maybe what we can do here is like this: int grid. Okay, so what I want to do now is to initialize a new array in C sharp. That's what I want to do. So yeah, so we will do something like this: equals to new int 5. So equals to new ints. There are 32 of them. Yeah. Then we also have a table cells. So basically, this is the equivalent of like the game object table here and the game object clover parent here. Okay. Okay. So the table cells, I don't think we'll use an int. Okay, because it can be dynamic. There can be a lot of table cells, so we'll use a list instead. So whenever you need something that grows in size or is dynamic, we use list. So something like that. New list int. Yeah, so this is what we'll do. Okay, so we have this list of table cells, and we have a list of grid cells, and we are good to go. So what we do now is we'll update the grid of the players. Okay, so for int I equals 0, I smaller than 32, I plus plus. Okay, firstly, we make the grid cells become 0. Okay, 0 means there's nothing there. Okay, so after that, we take the clover parents. Okay, and then for each of the children, okay, for each of the children, we will, okay, so we have a variable c, let's just call it clo equals c dot get component, this one. So after we get this, we can then update the grid cells. C dot my number equals to, okay, C dot my number is the number of, oh sorry, we should use the grid num actually. So C dot grid num, yeah, okay, so over here, if C dot grid num greater equals to 0, okay, then we update this. Grid cells C dot grid num equals to C dot my number. So this will basically just update the array, okay, so that we will have an array that is uh, so basically if there's something there, it will be updated to the clover value. If not, it will be given a 0 value. Okay, so that's updating the grid. Okay, we also can update the table. Okay, why we need to update the table? Because okay, so maybe we shouldn't call this in back to playing square. We should call it update tables, or maybe update values. Okay, so these update values will then update all this. Okay, why we don't call it here? Because later on there will be an option for the table to the playing square. So whenever we to play, update values like that. So we update our values now. So we update the grid values, and we also update the table values. So we'll do a table dot clear. Okay, so we have a table cells dot clear. Okay, we clear the array, and then uh, what we'll do next, okay, is to do a get component for the table. We have that already. Okay, we get all the components of the, okay, this one we call it children too, because we already have a children at the top. So we get all the children in the table, okay, all the clover in the table, okay. So actually this, I do not need this line here actually, because all these are clovers already. So for all these clovers, we will basically, add this thing to the table. So because everything that's under this table will confirm be in the table already. So table cells dot add c dot my number. That's all we're gonna do. So yeah. So we will have two values that will be changed: grid cells and the table cells. So all this later on we will be able to see what these values are. So maybe we'll have a print function, void print array. Okay, and then we'll take in the array. Okay, so we'll take in, I'm not sure whether we can take in a variable, but let's see. No, I think what we'll do is maybe we'll just print out these values. Okay, so print the values. So what we do is like that. Prints. Okay, maybe I have a string. Okay, string x for int I is 0, I smaller than 32. Okay, we can do like this. X plus equals to with cells I, okay, dot to string plus a space. Okay, so maybe this one will be called cells, grid cells, and then we'll add this, and then we have another string y equals to table cells, so that we know that these are updating correctly. So for int I equals 0, I smaller than table cells dot counts I plus plus, okay, y plus equals to table cells I dot to, okay, wait, let me just put this here so that you can see it. Table cells I dot to string plus a space. Yeah. Okay, then we just need to print x and print y. So this is for debugging. Okay, let me just put. So we want to see whether our grid cells and table cells are updated correctly, and that's what we are going to do. We're going to print out the values after we call the update. And okay, let's take a look, see whether is it okay. So let's play the game. Okay, then I want you to focus on the inspect on the console on the left here. So we should be able to see what are the cells that are being played. So table cells currently got nothing, but the grid cell, you see 40000. So it's 4000007, then 000013, 000020. Then after that 5000. So it does look like this represents the cell well. So let's just replace one to the table. And you can see that this has already changed. The table cells is 4. That's correct. We put this here. We put this here. And yeah, looks like the update is going well. If we go here, the table cell should have 417. Okay, so looks like we do have a working behavior already. So this print values for the cells, the debugging part, we can just comment it out because it looks like the update values function is working. And right now we want to place only, we do this function next, we want to place the clovers in the positions that it can be activated, means that only the valid playing positions will be activated. And what are these positions? Okay, so these positions are the positions, okay, that basically you need to check the left neighbor, check the right neighbor. Okay, so mm, yeah, maybe we should do 4 separate functions to check the left, right, up, down. Okay, so let me just do void check neighbor. Okay, with the u. Okay, so check neighbor. Actually, why not we just call check left, check right, yeah, check up. Okay, so in all this, what we'll need to do is we need to have the uh, okay, why not we just call it return neighbor value, and then in position, in current pos, and in direction. Okay, so maybe we call it a string direction. Okay, if string, if direction is up, okay, then we do this. Else if direction is down, then we do this. Else if direction is left, we do this. So this will just return, this returns the value of the neighbor in that particular direction. Yeah, and that's basically what we're doing. Okay, so else if direction is right, we will do this. Okay, so we have this return neighbor value here, and we want to return the value of the neighbor in that particular direction. So how do we do this? If the direction is up, okay, so we have this current pos value, right? So what we can do is, okay, we have a bool player one equals to, if the current pos, okay, because this current pos that we feed in will always be a value that is greater than zero. So maybe we can just put this: if current pos greater smaller than zero, then return false. Return minus one. Okay, it means there's no neighbor. Okay. Um, Otherwise, if it's greater than 30, if it's smaller than 32, okay, then it'll be true. If not, it'll be false. Okay. So this player one, or actually we just call it int offset. Yeah, so basically this is the offset for the grid. So if it's a player one grid, uh, we will actually take the offset and then we will just take the current pos. Yeah, so later on what we'll do is we will need to return the offset. So now this basically scales the position to a value between 0 to 6, 0 to 15. Okay, so everything is in perspective of one single player's grid. Okay, so we scale this position. Okay, so if the direction is up, we want to look at the topmost value. Okay, so if current pos is smaller than, okay, so if we want to scale up, we need to make sure that, okay, let's go back and look at this thing here: 0, 1, 2, 3. If we want to go up, we need to make sure that the number is 4 and above. Okay, if not, there's no neighbor, right? Yeah. So mm, mm. Okay, if the current pos is smaller than 4, it means that the up neighbor is empty. Okay, so what we'll do is we'll return a value 0. Okay, it means that all these positions are potentially, like, what do you call that? All these positions are always valid. So same thing for here. Uh, if current pos percent for is 0, that means it's the leftmost. Okay, we return 0. Okay, same thing for right. Okay, over here, if current pos, if this is always on the right, we return 21. Okay, because 21 is always bigger. So same thing for down. If current pos greater than, what are the four values at the bottom? 12, 13, 14, 15. So greater than equals to 12. So always return the maximum possible. Okay. If not, what we will return, okay, what we will return is that we will return the value of the neighbor that we perform the operation up. We return the value of that neighbor. So the it's called grid cells. So what we do is we return grid cells. Okay, current pos plus offset. Okay, now we put in the offset. Okay, current pos plus offset. Okay, minus away the operation of going up. So the operation of going up is actually similar to a subtraction of 4. Okay, so we just minus 4. Okay, same thing for down. Down we will just return a plus 4. Okay, because down means you go down one row. How about left and right? Left is like 1 to 0, 5 to 4, 9 to 8, 13 to 12. Okay, 8, you cannot go left anymore, but we already settled the edge case here, so it's just a minus 1, and going right is just a plus 1. So we can go back to our get return neighbor value. So left simply is a -1, so we can return a -1 like that. And right, we can return a +1. So this will tell us the neighbor of the cell. Okay, so right now we already have this return neighbor value. Let us go back to the clovers that can be activated. Okay, so what we'll do is we need to check for each clover, for each grid position, what are the valid places that can be put. Okay, so let's go here. So okay, if okay, what's my function called again? Return neighbor value. Yeah. Current position is I. Okay, and the direction is like up. Okay, so what is the clover value that we are trying to put here? So the clover value is called num. All right. So if num is smaller than, if num is greater than the left neighbor, and num is greater than the up neighbor, and num is smaller than the right neighbor, and num is smaller than the down neighbor. Okay, only then we activate the grid. Okay, so I realized something. uh because we're going to use the same thing for the bottom as well. So actually what we can do is like this. We can have an array. Okay, let's do the array here. So we have an array of bulls. Okay, and this one will be 32. Okay, so at the start of this, okay, playable. Okay, we reset the playables. If player turn is 1, then what we'll do is we will, okay, so first what we can do is we can check whether this is playable. So we can do this check function. So for int I is 0, I smaller than 32, we check for everything. Okay, so we're going to revamp this function a bit. We check for everything whether it's playable. If it is playable, then we just put playable I equals to true. Okay, then block out squares for other players. Okay, over here, up here will be like check all cells that are playable, lock out squares for other player. So if player turn is 1, okay, then what we do is for int I equals to 16, playable I equals to false. Okay, okay, otherwise we'll do the same thing. Okay, but we block out for player 1 instead. So like that, 0, 16. Okay, then over here, we don't need such a complicated thing anymore. Okay, we can just simply do for int I equals 0, I smaller than 32, I plus plus. Okay, if playable I, then we will activate that component. Okay, then we also will look through all the clovers like that. Okay, the reason why we have a playable array is because this clover also needs to know this array. Okay, so if playable, okay, c dot grid num, okay, then we activate that component. Okay, and then all this thing at the bottom. Woohoo! Wow, we saved quite. Oh, wait a minute. I exceeded. So yeah, we saved this chunk of code just by having a playable array. So sometimes having extra memory can help you reduce the amount of code that you do. So this is an instance, a perfect illustration of how like we can use this playable array, okay, to do this check. Okay, so we already checked all this. So we only need to check the neighbors once. Okay, smaller, greater than the left, greater than the top, smaller than the right, smaller than the bottom. So all this is cleverly done using this function called return neighbor value that returns the value of the neighbor. So let's brace for errors. Okay, if there's no errors, I'm a really good coder, but yeah, as you can see. Okay, so the return here shouldn't be a void, it should be an int because we are returning the grid cells. Okay, grid cells is an integer array. Let's see what other errors are there. Oh, look at that. Not all code parts return a value. Okay, so we're just gonna have to return something if let's say all this is not going to happen. So we just return uh, -1 maybe. Yeah, -1 is like error. Okay, so yeah. Now let's see whether our criteria is fulfilled. Okay, great. Play, and we see what will happen next after we play this. Index out of range. Grid number 220, line number 220, index out of range. Okay, so we need to do some checks. Yeah, so we need to make sure that the c dot grid num is uh is a positive, or basically greater than equals to 0. If not, there's no index of an array that is negative. So let's check it. Let's check it. Okay, so 19. Okay, right now, if it's 19, there should only be one playable square, which is this square here. Okay, but it's not being lit up. So there's some issue here. Mm, yeah, I can't seem to. So basically, no square is playable, which is weird. Okay, let's see. Let's print out what are the playable squares. So oh, I get it, because this num is. I see. Okay, so what we can do is we can have an integer here. Integers uh, current num. Let's just call it current num equals to current clover dot get component clover, okay, dot my number. Then we just change all this to current num instead of num, because the num itself can be the value that we have instantiated that is greater than 20. So none of the squares can be playable. So with this change, okay, get component. I must have spelled get component wrongly. So yep. With this change, let us check it out, see whether it's okay. Let me see. Let's see whether this is okay. So yeah, as you can see, these three squares are littered up, which means these three squares are okay to be played. Okay, let's try replacing this. Very good. So now you can see that these few squares are being littered up. Okay, maybe I'll change the color because I think golden may be a little too underwhelming. Like, okay, so there's some issue here. Okay, uh, we only check for the nearest neighbor. Okay, so like stuff like this square shouldn't be able to be placed. Okay, there's some issue with this because like I can place here right now. Like over here, how come I can place at the bottom? Yeah, I should be able to like get rid of this top one. I should be able to play here also. Yeah. So it means that if the square is empty down here at the bottom, okay, the square is empty, I shouldn't call it zero. Okay. Maybe I should call it like 20 or something. Yeah. So these are some stuff that I'll need to adapt. But overall the rules based placement seems to be working. Okay, I've got to go already. But I think it is a simple tweak to fix the rules update. Okay, so we'll fix the rules update here in the next stream, and we also incorporate a new move called table to grid. Okay, so this will be the two things that we'll do. And yep, I'll see you all next time. Okay, bye.